Welcome to Taxonomy Online Mathematics. We are continuing with the tuition on set and operations on set. In our previous lesson, we talked about definition of set, examples of set, and types of set. Now, under the type of set, we categorize that there are some that are under pair of set, where two or more sets are being combined to define that type of set. And we are left with the union of the set, the intersection of the set, and the complement. So today we are taking the first one under the pair of set, which is going to be union. Now when we talk of union of a set, that is just the combination of the two or more sets. If we have a set A, set B, set C, if I'm finding the union of the three sets, meaning putting all the elements in those sets together by definition. So as I said, by definition, we can say that the union of two or more sets is the set which contains a combination of all the elements in those sets. So we have talked about elements of a set. Those are the members of the set. Now, so if we know that so we use the symbol U to indicate union. So if, for example, I have a set A which contains the element of 2, 4, 6, then I have the set B which also contains the elements of 2, 3, 5, 7. So we can say these are the even numbers which are less than 8. Then we can also have prime numbers less than 9. Now if I'm asked to find the union of the two sets, which will be written as A union B, meaning the combination of all the elements in those sets. In this case, there are only two sets here. I'll combine all the elements. But bear in mind that when you are combining, you are going to write in ascending order without repeating any element. So if element belongs to A and the same time belongs to B, you write it only once. So in this case, combining these two sets, writing in the pattern which it will appear. I know the smallest number will be what? 2. In this case, followed by 3. The next will be 4. Then we have 5, 6, 7. So the union of A and B will be 2, 3, 4, 5, 6, 7. Even though 2 appear twice as in both sets. So if you are referring to union, you are only combining the element that belong to the two sets. Alright, let's take another example. Alright, so we have a question. Let A equals the set of x such that x is a natural number and a factor of 18. Natural numbers that are factors of 18. Then B is the set of x such that x is also natural number less than what? 6. So first of all, this is just stating the property. Let us list the element of the set A. So we know 1 is a factor of every number, so we begin from 1. After 1, 2 can divide. You know, factors are numbers that can divide the given number without a remainder. So we are going to have 2. You know, 2 times 9 will give us 18. 3 times 6 will also give us what? 18. Then from here 5 cannot go, so we go to 6. So 6 is a pair of 3. Then the pair of these will be what? 9. Then the pair of these become our 18 itself. So these are the elements of the set A. Then we have the set B, all natural numbers less than 6. So in this case, we are going to start from 1, 2, less than 6, meaning 6 is not included in the set. So if I have this, the question is find the union. Find the union of A and B, meaning combining the element of A and B, writing in ascending order. I believe 1 is the smallest number here, so I have 1, even though it appeared twice, I write it only once. Taking the next number after 1 will be 2. Even though it appeared twice, I take it at once. 3, which number again? From here I have 6, but 4 is smaller than 6, so 4. 5 will come, 6, then we have 9 and 18. So in combining these two sets, the value that we are going to have, or the element of this set, the members will be 1, 2, 3, 4, 5, 6, 9, and what? 18. So you can see that in union of a set, we are only combining the elements, putting the elements together. But don't forget, the definition makes mention of what? 2 or more. So far, we are dealing with what? Only 2 sets. Let's take a question that will give us more and see if union can be applied to that also. So we have given that A is a set of numbers 0, 1, 2, 3, 4, 5, B 2, 4, 6, 8, and C 1, 3, 5, 7. We have to verify that A union B union C is equals to A union B union C. You know, when we have operations involving brackets, we decide always to solve the one in the bracket first before operating in on the outside term. So I will take the first one here as in A union B, meaning putting the set A and B together, writing in what? Ascending order, without repeating any element. So I have 0. You can help me out from there. I believe we have 2, 3, 4, 5, 6, and what? 8. So this is the union of A and B. So now we are using this set, which is now this union, this, combining this set with the set C. So it becomes A union B as in one bracket union C, meaning putting this set together with what? The set C, writing still in ascending order. I believe the smallest will still be our 0, 1. So all these numbers here combined with this, we can see that after 6, we have 7 before 8. So here I have 7, then I have what? 8. So combining A union B as one set with C, that is union C, we get this term. So this is the left hand side. Let's try the right hand side, taking the bracket first, meaning B union C, putting B and C together. B and C together, starting from 1. So 1, 2, 3, 4. So we have 5, I believe 6, 7, so we can see that combining 1, 2, 3, 4, 5, 6, 7, and what? 8 will be the element of set B union C. B union C. So now that set is going to be combined with what? Set A, in writing ascending order. Since 0 starts from here, I'll have by 0, then all these numbers are in order. So 1, 2, so you can see that the element here 0 to 8, the element here 0 to 8. So as we are to verify, if we have this, will it be equal to this? And we can see that the two side, the left hand side is equal to the right hand side. So hence it is verified. The two sides are equal. So that is all about union, putting two sets together. Now let's take the next one, which will be the intersection, the opposite of this. So for the intersection of a set, to intersect, meaning both have something in common. That is overlapping. They overlap, meaning they have some common element. So the intersection of two or more sets is what? The set which contains elements which are common to those sets. The element that is common to the two sets. So as we have first, we have the set A, which is the set of x with the numbers, natural numbers, as a factor of 18. We have 1, 2, 3, 6, 9, and what? 18. We also have the set B, which is the natural numbers less than 6 in the example we did for union. And that was 1, 2. So if we are to find A intersection B, putting the two sets together, find out which of the elements are common, that are overlapping. In the union, the overlapping elements are written once. Here we are going to look at them and see which element intersect two sets. Here I have 1, 1, so 1 is common. 2 is common. I believe 3 is also common. 6 is here, it is not here. 4 is here, we don't have it there. 5 is here, it's not there. So to find the intersection of the set A and B is going to be 1, 2, 3, meaning the elements that are common to the two sets. That I can see in A, I can also see in B. That's intersection. Good. Then let's take another example. Good. Given that P is a multiple of 3 between 1 and 20, and Q is even numbers less than what? 15. We have to find P intersection Q. Meaning, if I take P, what are the elements? I need to list the element. This is just the stating of properties. Multiples of 3 between this. So the first number as a multiple of this, multiples of a number is multiplication of the number by counting numbers. So 1 times this will give us what? 3. So we have what? 6, 9, 12, 15, 18. The next will be 21, which is bigger than 20. So we end our set here. Let's take Q. What are we looking for? Even number less than 15. Even number starts from where? 2, 4, 6, 8, 10, 12, and what? 14. So in terms of intersection, which of the element intersect? I can see in A and see in B. That is P and Q. Taking 3, I don't have counterpart. 6, counterpart, so 6. 9, no counterpart. 12, a counterpart, so I have 12. From there, what again do I have? 15 is here. We don't have it here. So I think we end our value of P intersection Q out here. So you can see intersection, the element in A that can be seen in B. The element in Q that can be seen in P. You put them together to form the set of intersection. That's the intersection. Alright. So the third one, we have complement of a set. So if the universal set E is a universal set and A is a subset of the universal set, then the complement of a set A is a set of all elements of the universal set which are not in the element of what? A. We use the symbol A prime or A subscript C to indicate a complement. What they are saying is that if you have element of a universal set, as in these are the elements of the universal set, the set under discussion. Then I have the set A if I am looking for the complement of the set A, I am looking for the elements that are in the universal set but are not found in the set A. The complement of A, the element in the universal set, in the mother set, that are not found in the given set. Because the set A is a subset, it's a family of sets of the universal set. So it means that the elements that are supposed to be here, that are not here, will be 2, 4, 5, 6. These are the elements which we call the complement of the set A. You can see 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There are 7 elements under discussion here are in the universal set. 3 of them are in our A. Then the complement will be the remaining elements in the universal set that are not found in the set A. I believe the concept of complement is clear. So if you have the mother set, the smaller set form from the mother set, all those elements that are in the mother set are not in that given set become the complement. Don't forget, a complement of a universal set is empty set. If you find the complement of universal set, that will give you an empty set. Then the complement of an empty set give you back the universal set. Alright, so this will be the remaining 3 types of sets that we did not treat in the first episode. So I believe the concepts are clear. We will have a question later which will combine all these 3 types together in one question. Meaning in the next episode we will take the Venn diagram, how we are going to use the Venn diagram to represent union, intersection and complement. Then from there we will take the operations on set, distributive property, commutative and what? Associative property. Don't miss that, please. If you've not subscribed, please subscribe to the channel, like, share and leave your comment as we continue to interact together. See you in the next episode as we take the representation of this set on a Venn diagram.